Imagine this: you're standing still, but the entire world around you freezes. Cars halt mid-motion, birds hang in the air, and even the wind stops whispering. Is this just a fantasy from movies, or could physics actually let us stop time? What if I told you that science is closer to unlocking this secret than you think? Buckle up, because today we're diving into the mind-bending world of time itself. Can we stop it, bend it, or even reverse it? This is Can We Stop Time? The secrets of physics unveiled. Let's start with a big question that's haunted philosophers, scientists, and dreamers for centuries. What even is time? Is it a river flowing endlessly forward, or something we can dam up and control? In everyday life, time feels absolute. A second is a second, no matter where you are. But physics tells a different story. Show a clock ticking normally, then distorted with gravitational waves rippling across the screen. According to Einstein's theory of relativity, time isn't fixed. It's flexible, stretching and compressing based on speed and gravity. This isn't some abstract idea, it's been proven in experiments that make your head spin. Think about astronauts orbiting Earth at breakneck speeds. Data from atomic clocks on satellites, like those powering your GPS, show that time ticks slower for them compared to us on the ground. In one famous 1971 experiment, scientists flew precise clocks around the world on jets and found they lagged behind stationary ones by tiny fractions of a second, exactly as predicted. Show split-screen visuals. One clock on a plane zooming through clouds, another on solid Earth, with numbers drifting apart. This effect, called time dilation, means if you travel fast enough or get close to a massive object, time for you slows down relative to everyone else. Near a black hole, for instance, time could crawl to a near halt. Recent studies, like those exploring gravitational time dilation on Earth, even suggest our planet's pull warps quantum effects, hinting at deeper connections between gravity and the tiniest particles. But stopping time completely, that's where things get thrillingly complicated. In the problem at hand, stopping time isn't about freezing the universe like a pause button. Physics doesn't allow that without breaking everything we know. Instead, it's about manipulating how time flows for you or around you. Show an animated hourglass where sand slows to a trickle near a massive black sphere. The core issue is entropy, the universe's tendency toward disorder, which drives time's arrow forward. Reverse that, and you'd need negative entropy, something that sounds impossible but pops up in cutting-edge quantum research. While some skeptics argue true time reversal defies causality, think grandfather paradox. Recent breakthroughs suggest ways around it. For example, physicists have created time mirrors that reverse electromagnetic waves, effectively bouncing signals backward in time on a tiny scale. It's not full-on time travel, but it's a step toward bending time's rules. Now, let's unpack the current state of play in physics. We're not talking outdated textbooks. Real-time insights from ongoing research paint an exciting picture. Show lab scenes with scientists peering into particle accelerators, overlaid with quantum equations flickering like code. Time dilation is old news, proven repeatedly, but new twists are emerging. Just last year, experiments at places like NIST showed clocks differing by mere centimeters in height due to gravity's pull, confirming time slows in stronger fields and black holes. They're nature's time machines. Near their event horizons, time dilation becomes so extreme that if you hovered there, ignoring the deadly spaghettification, years could pass back home while minutes tick for you. Data from observatories like the Event Horizon Telescope, which imaged black holes, supports this. Light itself bends and time warps around these cosmic beasts. Diving deeper, quantum mechanics adds fuel to the fire. Recent papers explore how gravity might warp quantum states, potentially allowing time-like effects in labs. One study from physicists suggests Earth's gravity could be influencing quantum mechanics in ways that mimic time dilation on a microscopic level. Show electrons swirling in a quantum dance, slowed by invisible gravitational tugs. And then there's negative time. Yes, you heard that right. In discussions among experts, manipulating zero-point energy, the baseline hum of the universe, could create regions where time effectively runs backward. It's speculative, but grounded in math. Equations like T equals T0 divided by the square root of 1 minus v squared over c squared show as you approach light speed, time approaches zero. GPS systems adjust for this daily, proving it's real. While critics point out we can't exceed light speed without infinite energy, advances in metamaterials engineered substances that bend light and waves are letting us simulate these effects. A team recently reversed waves using a custom metamaterial, creating a time reflection that could lead to temporal cloaking, hiding events in time. But it's not all labs and equations. The buzz on platforms like X echoes this excitement. Users are debating how frequency modulation could let advanced beings phase just ahead of our reality, making them invisible yet felt like ghosts in the machine. One post describes time as a pressure differential, not a line, suggesting we can detach locally with the right neural coherence. Show abstract visuals of timelines branching like lightning, with user quotes fading in as ethereal text. Another shares how photons experience no time at all. Emission and absorption are instant for them, tying into how our cells detect light, essentially reading cosmic history in real time. These ideas aren't fringe, they're inspired by solid science, like the discovery of time cells in the brain that track internal time independently. It means our perception of time is as malleable as the physics behind it. Looking ahead, the future implications are nothing short of revolutionary. If we master time dilation on a practical scale, imagine the possibilities. Space travel transforms. Journeys to distant stars that take centuries for Earth could feel like weeks for crews, thanks to high-speed dilation. Show a spaceship blasting off, stars streaking by as clocks inside tick slowly. Medicine could benefit too. Slowing time in localized fields might preserve organs or even extend human life. Recent fusion and zero-point energy research hints at tech that manipulates energy density to create these bubbles. While some experts doubt we'll see this in our lifetimes, breakthroughs in quantum computing are accelerating simulations of complex outcomes, letting us predict and perhaps influence time-like behaviors. On the flip side, it evokes urgency. What if unchecked? This leads to inequalities. Those with access to time-slowing tech live longer, while others age normally. But optimistically, it could solve global crises, analyzing vast datasets in slowed computational time to cure diseases or combat climate change. Show futuristic labs where AI crunches numbers in dilated bubbles, sparks of innovation bursting like fireworks. And in energy, reversing entropy locally could mean unlimited power, drawing from the universe's vacuum. Though skeptics warn of paradoxes, logical reasoning suggests closed time-like curves. Loops in space-time could allow it without breaking reality, as explored in string theory models. Now, for the speculative scenario that will leave you breathless. Picture this: it's 2050, and you've volunteered for the first human trial of a time dilation chamber. You step inside a sleek pod, humming with metamaterial shields and quantum stabilizers. Show the chamber glowing blue, energy fields pulsing like a heartbeat. As it activates, the world outside blurs. For you, seconds pass, but monitors show hours flying by externally. You emerge, and the lab team cheers. Your biological clock has barely moved, while they've aged a day. But push it further. Imagine scaling this to black hole tech. Humanity builds orbital stations near simulated singularities, where researchers stop time to ponder universe-shattering problems. In this bold future, conflicts arise. A rogue group hacks the system, creating a negative time bubble that reverses local events, undoing accidents or even assassinations. Society grapples. Is this godlike power or a Pandora's box? You, the viewer, might live in a world where vacations last weeks internally, but seconds externally, letting you explore virtual realms endlessly. Show people in pods, dreaming through dilated adventures, emerging refreshed. Yet, wonder turns to awe as we realize time's illusion. Perhaps we're already in such a field. Our lives echoes in a grander cosmic loop. This isn't fantasy, it's plausible, built on today's physics, sparking curiosity about what's possible. But let's zoom out. The real question isn't just can we stop time, it's why we want to. Is it to live longer, explore further, or understand our place in the cosmos? Every breakthrough, from quantum time mirrors to black hole observatories, brings us closer to answers. Show a montage of stars, labs, and human faces gazing upward, united by wonder. This journey isn't just for scientists, it's for all of us. Comment below. What would you do if you could slow time for a day? Would you explore, create, or just savor the moment? If this blew your mind, Hit that like button and share this video with someone who needs their reality shaken. Subscribe and ring the bell for more deep dives into the universe's biggest mysteries. We're just getting started. Let's keep chasing the secrets of time together. Until next time, stay curious and keep asking the big questions.